Personal finance practice problem using Excel. Annuity due or annuity where the payment is due at the beginning of the period. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, we're going to populate that into the blue area on the right-hand side. We're looking at an annuity situation, which is a series of payments. A normal annuity, usually assuming the series of payments happens at the end of the period. Now we're going to basically assume the payments are happening at the beginning of the period. So we got the payment amount, which is going to be the $1,000. We got the rate at the 5%. The years are going to be 6 years. We're going to do a future value calculation of an annuity, and we'll do one for the standard annuity and look at the difference if we were to calculate the annuity due or the series of payments happening basically at the beginning as opposed to the end of the time frame. So let's first do that with just simply the Excel functions. Normally, the normal standard annuity, if I'm looking at the future value of annuities, meaning I'm going to make a series of payments every year, assuming at the end of the year for 6 years at a 5% rate, where will we be in terms of a future value? We're going to say this is, I'm going to start with a negative to flip the sign at the start, which is going to be future value, shift 9. We'll pick up the rate, which is going to be the 5%, comma. The number of periods is going to be the 6 periods, which is going to be the years, and then comma. And the payment is going to be the 1,000. So this is what we have seen in the past. Notice that we haven't been using these other two components here because by default, we're at the standard annuity. But notice if I hit a comma again, I'm going to say comma. That gives us to the present value. We don't have one. Comma again. That takes us to the type. Now the type says here the default is basically end of the period versus the beginning of the period. So we're by default typically having this end of the period or zero calculation. So in other words, if I was to hit the zero calculation here, we would then have the type added and then enter. That'll give us this 6,802. If I double click on this again and I remove the zero and just remove these last two fields which are not required, it will by default give us the same calculation of the 6,802. Now, if I want to change that, then I can use that type field to make the adjustment away from the default, which is to say it's at the beginning of the period. Let's see what that would look like. So it's going to be the same starting point. This will be the future value, shift 9. The rate, once again, at the 5%. Then comma. We got the number of periods. The number of periods is going to be 6, comma. And then the payment is going to be the 1,000. And then comma. I'm not going to put a present value here. I'm going to put another comma. And note the present value is typically there when you're not doing an annuity where you would skip the payment and use the present value. This time I'm going to skip the present value to get to the type calculation, which I do want to use because I want to remove myself from the default and go to this one with it, which is indicated with a 1, the beginning of the period. So I'm going to select that one. That'll put a 1 for the type. Now we could close it up, or we can leave it as is and then say enter, and we get then to a different result, a larger result, because we're assuming here then that the payment went in at the beginning of the period. Let's see if we can make some more sense of this by basically putting these two into the table. We'll start at our first table doing the standard kind of annuity and then compare it to the one at the payments happen at the beginning of the period. So note, with a standard annuity, I'm not going to put a time period 0. I'm going to start at 1, 2. I'm going to select those two cells, put my cursor on the fill handle, drag it on down for our 6 periods, home tab, alignment, center, and then the payment is going to be equal to the 1,000 at period 1. Notice that no interest is going to happen, no increase in the value due to the fact that we're assuming it happened at the end of the period 1, end of the year in this case. So the investment at the end of the year will still be the 1,000. Then we're going to calculate the increase, which would be interest or whatever the increase would be, increase in value if it was stocks or something like that, in the next period, which would be the 1,000 times, we're going to say the 5%. I'm going to select F4 on the keyboard because I will copy this down since we've seen this one in the past. So F4, $ before in the B and the 2, before the B and the 2. and that would mean it's absolute. It's not going to move down. You only need a mixed reference, but an absolute reference is easier to kind of think about 50. Then we're going to be saying the payment is the same at the 1,000. That's also something I don't want to move down, so I want to make it absolute by selecting F4, $ before the B and the 1. Once again, you only need a mixed reference, but an absolute works. Then we're going to have then the investment, which is going to go up by both the 1,000 and the $50. And that's going to be calculated as the 1,000 we started with in J2 plus, I'll say plus the SUM, the sum, shift 9, left arrow of these two items. The 50 plus the 1,000 plus the 1,000, closing the brackets, and there we have the 2,050. Now I'm simply going to copy those cells down. I'm going to select these three, put our cursor on the fill handle, autofill, and copy that on down, dragging it on down. That gets us to our end result of the 6,802. We would have put in 6 payments, giving us the $6,000 over the 6 years, and the amount of increase we had, if we sum this up, would be the $802. Now, this one will be a little bit more confusing if we think about the payment that happens at the beginning. So I'll set the table up 2 different ways so we can look at that. The first way, we might do the same kind of process. We're going to say we got 0, 1. I'm going to start at 0 this time instead of at 1 and copy that down. I'm going to copy this down to 6 periods. And then I'm going to go to the Home tab, Alignment, and Center. And then I can think about period 0 as basically the starting point, meaning the end of period 0 would be the beginning of kind of period 1. So the payment kind of happens at the beginning of the year you're thinking, which I'm going to say is at the end of, period 0. So that you got the same kind of starting point. So I'm going to say this will then equal, actually, let me put that in the payment. The payment here is going to be equal to the 1,000. And that means the investment is going to be the same at the 1,000 at that point in time. And then I'm going to say in period 1 then, now we're actually going to be calculating interest in period 1 because we're assuming that we had it at the beginning of the period, and therefore interest will be calculated for the year of period 1. And we're indicating that by having the investment amount at the beginning of the prior period so that we can have a similar table formatted. So let's see what that would look like. This would be equal to the 1,000 times. I'm going to scroll up and pick up the 5%. I don't want that cell to move down again, so I'm going to select F4 on the keyboard, $ before the B and 2, making it absolute so that when I copy it down, it does not move down. Note you only need a mixed reference, but the absolute works. Then the payment is going to be equal to, and I'll pick up the 1,000. I want to make that absolute, so when I copy it down, it doesn't move down. F4 on the keyboard, $ before the B and the 1. And then we have a similar calculation here. We got the prior amount, 1,000, plus the sum of shift 9, left arrow, holding down shift, the 50 and the 1,000, shift 0, closing it up. 1,000 plus 1,000 plus 50, giving us the 2,050. So then I can copy this down. This is a similar format, just kind of a different starting point. Selecting these 3 cells, we're going to copy that on down. Let's do the good old copy down here. And so there we have it. We have the similar layout. Now, you can say, well, this doesn't quite make sense because now I've made 7 payments here of 7,000. And so what we're going to do is basically delete this last one, and that'll give us to our balance of the 7,142. So it's a little bit staggered in the format, but hopefully that might be clear to you. We'll try a different method too, so that might click a little bit more. But remember, this period 0 actually represents kind of the beginning of the year. So we put it at the beginning of last year of the 1,000 so that we can have the same structure and then calculate this the same way. And then the $50 is being calculated on the 1,000 that we put in period 0, but we're kind of assuming happened at the beginning of period 1, earning the 50,000 in period 1. And then we had another 1,000, which is a little confusing given the fact that 1,000 would be there at the beginning of basically period 2. So in other words, at the end of period 1, you really got the 1,050 that would be in there as you accumulated the interest. This payment then would basically happen at the beginning. You could think of these 2 days at the same day, right? At the end of the first year, the first day of the second year, the next 1,000 going in, bringing the amount up to 2,050, calculating the interest on that would be at that 103, and that would be what we would have at year 2. Then the 1,000 would be put in again. Really, what would happen is at the beginning of year 3, you'd put the 1,000 in at the first day. We got it up top, kind of imagining the end of year 2 and the beginning of year 3 being basically the same, and so on and so forth until we get to year 6 here, which once again doesn't have a payment because we put the payment at the end of last year, at the end of year 5, so that we could calculate the interest on it, and then we get to our ending balance. So this structure is the same format. We can come up to a little bit more complex of a table, which might give us a better kind of grasp of this. So let's make a little bit more complex of a table and see if that makes it click a little bit more. This time we're going to start with year 1, 2, and so on. Same kind of format at the starting point. And I'll pull this down. And then we're going to go to the Home tab, Alignment, and center it. And then we could say, okay, let's start the payment at the beginning of the year. So I'm going to say this equals the $1,000 payment. I'm going to select F4 on the keyboard, F4 to put dollar signs and enter. And then we're going to stay at the start of the year, and we'll say the start of the year balance versus the end of the year balance. So the start of the year balance, which will be that $1,000. And then we're going to calculate the increase for that time period, which would be from January 1st to the end of year, December 31st, all in the same year, we're saying. So this is going to be equal to the 1,000 times, and we'll scroll on over to the 5%. I'm going to select F4 on the keyboard to make that absolute. So that times the 5%, and then we have the end of the year balance. So now we got 2-year balance, right? Beginning and end equals the sum of the 1,000 and the 50. So then we can say, all right, the payment for year 2 is going to happen at January. It's going to be the same. I'm just going to say equals the one above it this time. And then the year start balance will then be equal to the 1,050 plus the 1,000 we put out in the beginning. So that's our January balance, January 1st balance. It's going to increase during the year, January through December, by this equals the 2,050 times. I'm going to scroll all the way over to that 5% again. The 5% and enter. So there we have that. And then the year end balance would be equal to the sum of the beginning balance plus the 30103, about getting us to that 2153. And then we'd have another payment, which would be 1,000. The starting balance would then be equal to the 2,153. I'm sorry, hold on a sec. The starting balance, would be equal to the 2,153 plus the 1,000. And then the increase would be equal to that 3,153 times, scrolling over, the 5% up top. And then we'd have our ending balance equal to the sum of these two numbers. And there we have it. Let's do it one more time. And this time we'll figure that we're going to copy it down. Note that I didn't use an absolute reference here. I'm equaling the one above it. That's also another method, if this whole column will be the same, that you can do instead of using the absolute method, absolute value. So I'll keep that. The year start balance is going to be equal to this number, the prior year end balance, plus the 1,000 payment. That's the January balance. They're both within the table. There's nothing I need to do for absolute references there. Then the increase is going to be equal to that 4,110, 4,310 times. I'm going to go all the way left and then up to that 5%. That is outside the table, so I'm going to make it an absolute reference, selecting F4 or putting a dollar sign before the B and the 2. And then over here, the year-end balance is going to then be equal to the sum of these two. There's nothing outside the table, so I should be able to copy that down. And then if I select these 4 columns and put our cursor on the fill handle and drag that down, then we get to that 7,142 once again. So this one might make a little bit, more sense, but obviously we had to structure the table a little bit differently than we had over here, or how you might structure the table in a normal type of annuity. And just want to point out that obviously it's the same kind of thing that's happening. It's just basically when you're calculating, the payment to be made at the beginning or the end of the period.